right, indicator 29.2, correlation versus causation. You only have two definitions to write down, then it's just a lot of talking by me, not by you. Well, maybe if I can get it up there. Come on. There we go. No, hang on. I'll get it up there. That right there is what you need to write in your notes. The definition of correlation, the definition of causation, and that there's negative and positive of both. If you're at home, if you need to, pause the video and get this all written down in your notes and then hit play again when you're ready to go. Are we close? All right, so when you're talking about correlation, if you think about if two things correlate together, okay, they go together, but they don't cause each other. And I think there's a very fine line between correlation and causation. And some of these, when we get into some of the examples, I could actually see how there'd be an argument for both. And so again, just like with the other, with indicator 29.1, I think if you explain your answer and it makes sense to me, I'd give you credit if your explanation made sense, okay? And some of them are obvious and some of them are not so obvious. So we'll kind of talk about that here in a second. So causation means that one thing causes the other. Like there is definitely, without this one variable happening, the other would not have happened, right? So let's look at some examples. And you don't have to write these examples down in your notes unless you feel like you need them to go back and look at. But you really don't need to take the time to write these down. We're just going to talk about some of these. So the first example is the more shy a student is, the lower the test score. That is considered correlation, right? Being shy doesn't make you do bad on tests. It's just, trends show that the shyer a person is, they tend to also do bad on tests, but one doesn't cause the other. So for this one, it would be correlation. The reason it's negative, and this is, you just have to watch the wording of the problems. More shy is a going up kind of word, and lower the test score is going down. So when they go the opposite direction of each other, when one thing goes up and the other thing goes down, it's considered negative correlation. Okay? All right. The older a person gets, the less recs they are in. Okay, the older they get. So their age is going up, their recs are going down. So that's what makes it negative. And getting older, aging doesn't make you have less recs. It's just older people tend to do have less recs, but it's not something that directly causes it. And that's why I say these are really it's kind of a hard thing to teach, and it's kind of a hard thing to assess because it's just a fine line between the two. Okay. And this next, some of them are kind of obvious, right? Now, this one, I could see an argument for both. The more soda you drink, so your soda consumption is going up, the higher your chance of obesity. So you got two things going up, which is why you have positive correlation. But in this particular example, they call it correlation, right? The more soda you drink, the higher the chance of obesity. I could kind of see this as causation as well, because soda is full of sugar, and does sugar cause obesity? It does. So this would be an example of one that I could see either way. Okay. And as long as your explanation made sense, then you'd be good to go. All right. The higher the temperature, the faster a popsicle melts, right? Temperature goes up, and you kind of have to think about this. Faster you think about it going up, but what's happening to your popsicle? It's melting or getting smaller. So you kind of have to really pull apart what each thing's being compared here. But the higher temperature, the smaller your popsicle gets, right? The quicker it melts or goes away, when it melts, it's going down, right? So that's negative. This is definitely causation, right? You have got temperatures going up. If you think about it, would that popsicle melt if you were standing in the middle of a freezer? It's definitely the temperature that causes it to melt, okay? Whereas I guess with obesity and soda, you could say, could you get obese without drinking soda? The answer is probably yes. There's a lot of things that cause obesity, and so maybe that's why they go with correlation there. But with high temperatures and melting popsicles, if you're standing in a freezer, that popsicle's not going to melt. So the higher temperature definitely causes it to melt, okay? The higher the blood alcohol content, so the higher the blood alcohol content, the slower your physical reaction time is. So one's going up, one's going down, so it's negative correlation, or negative, and this says causation, which obviously would your slower react with, if you were out in the evening and you didn't have anything to drink, you wouldn't necessarily see a slower reaction time, but blood alcohol level definitely causes a slower reaction time. So this one would be an example of causation. All right, so that's pretty much it as far as examples on that. We're going to go through the homework here in a second together, but I want to talk about dependent variables and independent variables, and I do want you to put this in your notes really quickly. And I know we only have a minute or so, so we've got 3 minutes, and we can easily make it through this if you write fast. So the dependent variable is always on the y-axis, and the independent variable is always on the x-axis. So you have to ask yourself, and we're going to use this temperature and this popsicle melting as an example. One of them is an independent variable, which means it's going to happen without the others being around, right? So our temperature is going to rise with or without a popsicle present. Yes? Do temperatures rely whatsoever on a melted popsicle? So temperature is your independent variable here. Temperature is your independent variable because it does not depend on the other variable for anything. Now, does the popsicle melting fast or slow, does that depend on the temperature? So that is why in the popsicle example, that is why the time, I'll call it the melt time. The melt time, it would be your y-axis, because the melt time is definitely, in this example, the melt time is your dependent variable. Okay? So don't start putting everything away. We've got 5 questions to work through really quickly. We're going to do it really quickly, and then you won't have homework. If everybody starts packing up and you're not listening, then I'm going to assign this as homework. Okay? So just really quickly. Just everybody say it out loud and tell me what you think. And there's an argument for both. So the higher the sales at Subway, the less sales at McDonald's. Does one cause the other? They can trend together, but does one cause the other? So it would be correlation. And negative because high and one goes low. Good. The more people at a ball game, the greater concession stand sales. I could see this one as either one. Okay. More people, greater sales. So this one would be positive. The hotter the day, the higher attendance at a city pool. Yep. I could see that one I could really see it as either. Hotter day, higher attendance would be positive. And then let's just do one more. The lower the temp, the higher sales of coffee at McDonald's. What do you think? Correlation? And then one goes low, one goes high. Negative. All right. Listen up real quickly. Tomorrow there is a small assignment on Canvas. It's the review for indicator 29. As long as you explain your answers, you're pretty much guaranteed 100%. So just make sure you explain your answers and have a great E-Day. For everybody at home, email me if you have any questions.